Okay, so now let's assess the probability that 3-1 is a carrier. This one's a little bit more complicated because there's more than one way for this to come about. And as you can see from the matrix, there's a number of different options. So the probability that they are a carrier could be explained a number of different ways. Typically when I'm working through one of these matrices, I like to start at the top and work my way down. As now essentially what we're going to do is say, well, it could happen this way, or it could happen this way, and so on. So the first way to be big A, little a, is I look in this little part of the Punnett square here and I say, yeah, there's some here. Okay. So one way for this to happen would be for this string to happen. 2-2 to be big A, 2-3 to be a carrier, and then half of those offspring would fulfill this requirement. So the way I do that is I just make note of the different probabilities in the string. And then, so it's 1/3 times 1/2, and then you could, if you wanted to, break this up and say, well, this is a quarter and this is a quarter, and we use the sum rule to put those together. If you're okay with just looking at that and saying 1/2, then that's good. But then at this point, we'd have to say or, and then we go down here. Are there any big A, little a's in this string? And there are. There's some here. So 2/3 times 1/2 times 1/2. And then we would also have to say or. Okay, and we go down here. You'll notice that there are no heterozygotes in this particular category, so we can just skip this one altogether. This one does not give us any of the offspring that we're interested in. Now, if we then go on to do the big A category, then we would have to include them because it would be 1/3 times 1/2 times 1 for that big A category. But because we're doing the heterozygote here, we can totally skip this one. Okay, there are some heterozygotes here. So 2/3 times 1/2, and then 1/2 of those. Okay, so the thing you do then at this point is you simply go through and work out the math. So now you're just number crunching. Okay, so 1/3, 1/6, 1/12. Hopefully I'm doing this right. 2/3, 1/3, 1/6. 2/3, 1/3, 1/6. Okay, so 1/6 is 2/12, so 2/12, 4/12 should equal 5/12 as your total. Just one piece of advice. You might be tempted to work in decimals. It's much, much better to work in fractions because then you won't have any rounding errors that add up. So the question is, what's the probability that 3-1 is heterozygous? And our final answer is 5/12. Okay, then the last step, of course, is just to tackle the final probabilities of the final genotype, big A. And if you work your way through exactly like I just did in the last segment, these are the numbers that you should get. You'll notice that it comes out to 6/12 and 6/12. So we had 6/12 for this genotype, 5/12 for this genotype, 1/12 for this genotype. As a final check, this needs to add up to 1, and as you can see, it does. So with this approach, you can tackle the probability, determining the probability of the offspring of two individuals with an unknown or ambiguous genotype, where it's a probability for either or both.